All right. So let's talk about some of these vocabulary words. So before we talked about a chord being any line within a circle whose endpoints are on the circle, and a diameter being a chord that goes through the middle of the circle. Okay. We talked about the radius, and radius being from the middle of the circle to the end of the circle. Now, the things that we didn't talk about was a secant and a tangent. And all a secant is a line that starts from the outside and goes through the circle and intersects the circle at 2 points. So the secant intersects it at 2 points. So basically the secant makes a chord within the circle. So the entire line is known as a secant. The portion that's on the inside is your chord. Okay. Now, the part of the circle, when you have a line outside the circle that doesn't cross it at 2 points, but only crosses at 1 point,
Tangent.
that is known as a tangent. Okay. And this is pretty important. All radiuses and diameters that intersect a tangent form 90-degree angles. Okay. All radii and diameters that intersect a tangent form 90-degree angles. And the point where the tangent intersects the circle, that 1 point, is known as the point of tangency. Okay. So the radius and the diameter is perpendicular to a tangent at its point of tangency. So that brings up a pretty interesting question. What if I had a circle and a tangent to that circle, and I knew the radius was, say, 12. This length on the tangent is 5. What would this piece right here be? How would we figure that one out? Any takers? Okay, so let's talk about it. This thing right here is 90. So what type of triangle is this triangle right here?
A right.
A right triangle. What is the relationship between the 3 sides of a right triangle? What is the famous theorem that relates the 3 sides of a right triangle? Starts with a P. How are the 3 sides of a right triangle related, guys? What do we call that theorem? I'll give you a clue. A, B, and C.
Pythagorean Theorem.
Pythagorean Theorem, which says a squared plus b squared equals c squared. Okay. So if I know that this piece right here is 12 and this other piece is 5, what can I say about the length of this piece? How long would that be? How would we figure out the length of that piece? Somebody do the calculations. What'd you get? So 1 leg squared plus the other leg squared equals the hypotenuse squared, because I'm looking for the hypotenuse, which means the hypotenuse is 13. Okay. So what is x? Is x 13?
No.
What
No.
would x be? If the whole thing is 13, how can I figure out what x is? So here's something. How long is this red piece right here? What is the length of that red piece? From here to here, what's the length? Well, think about it. If this is, what is this thing called?
Well, what?
What is that thing called? What is the line that goes from the center to the edge of the circle called?
Radius.
The radius. And if it's 12, guess what this length is? From this center
Oh,
to the edge?
12.
12. So if the whole thing is 13 and a piece of it is 12, what does that make x?
1.
1. Does everyone see how we did that?
Yeah.
We said that the radius is perpendicular to the tangent at the point of tangency, and it forms a right triangle. And we can use the Pythagorean theorem to find the sides. And we know that if one radius is 12, every radius in the circle is 12. And if the whole thing is 13 and piece of it is 12, the rest of it is 13 minus 12. So let me give you all another example. I want y'all to do it. Find x. What'd you get? Anyone got an answer yet? Remember, if you have an answer, you are muted, so unmute yourself and we'll go from there. So question, got a suggestion. What is this length right here? What would that entire length be?
12 plus x.
12 plus x, but what is it? How can I figure out what the actual measurement is? I know I have enough information to figure out what that length is. Because what type of angle is this guy right here? What's the measurement of this angle?
90 degrees.
90. So what does that make this entire, what type of triangle am I dealing with here?
Right triangle.
Okay, so how can I use my knowledge of right triangles to find what that whole line segment is?
12 squared plus 16 squared equals x squared.
Not x squared, but the whole thing. So say C. So what is C if I plug it in?
Um,
What is C if you plug it in to your calculator? So 144 plus 256 C squared. So C squared is 400. So C is 20. Okay. So if C is 20, what is X?
8.
8.
8.
Okay, any questions on how to do these types of problems?
All right.
No.
Okay. So remember before we left, I said that of the 2 circles tests that you were going to have in my class, the harder circle test was this one. And that's because there's a lot of relationships between tangents and circles, between secants and circles, and tangents and secants and circles. So this is just the tip of the iceberg. The more you get into tangents and secants, you're going to see that the problems are going to get much, much more difficult. And this is why. This is just one type of problem. Okay. But we will tackle it as we get to it. Now, we talked about central angles in the last chapter. And we talked about arc measure. Remember, the arc measure is the measure of the curve of the arc. So if the central angle is, say, in this case, say 100 degrees, what is the arc measure?
100 degrees.
100 degrees, good. Now, we also have, not only do we have the measure of the curve of the arc, that's the arc measure, but we also have the length of the arc, okay? And that's known as arc length. So a couple of formulas that you need to know. So circumference formula, remember, is pi times diameter. Arc length is the circumference times the arc measure divided by, I'm going to replace A with that. Okay. So if I had a circle whose, say, radius is 6, what would the circumference be?
12.
12, yeah. 12 pi, okay? Because remember, if the radius is 6, the diameter is double that, so it is 12. Okay. Now, if the circumference is 12 pi, how do I figure out what my arc length is? So it's the circumference times the arc measure divided by 360. And you plug that into your calculator, you get a number. Okay. Now, another thing about circles that you need to know is the area of the circle. So given a circle with a radius of r, the area is pi times the radius squared. Okay. The area is pi r squared. Now, let's say, for example, I have this little wedge. Okay. This is known as a sector. A piece of the circle is known as a sector, okay? And the area of a sector is the area of the circle times the arc measure divided by 360. So if the radius is 4 of this circle and say the central angle is 60 degrees, the area of the circle would be 4 squared times pi, which is 16 pi. The area of the sector is the area of the circle times the angle measure divided by, or the arc measure divided by 360, whatever that is. And we didn't talk about this formally in class because most of the time, whenever you take a standardized test, they're going to give you formulas like this. And it's just knowing what is a sector to be able to do this and to do this stuff. But we've already covered in our classes what is an arc length, what is the central angle, how is the central angle related to the arc measure, and how to use the circumference and the arc measure to find the arc length. So the only new thing that is introduced in this section is the area of a circle, which most of you should already know from, I guess, grade school. And the new thing is the area of the sector. Any questions? Guys, I know this is like, you probably are like, this really sucks and this is boring and stuff, but think about it this way. Eventually, you guys are going to go to college and you'll be invited to parties, and you can get thrown out of a party like I did by sitting down next to the person who's drinking and say, you know what, you're going to eat that pizza and I can calculate the area of the pizza that you're going to eat. So, trust me, I've been thrown out and beaten up because of that. So it's a good way of, you know, getting evicted, if you will. And bullied as well. So, any questions?
No. Mr. D, could you do one like, you know, the dilation of like one circle and then the smaller one, you put it together? And
Yeah, that was so complicated. I don't understand that at all.
The dilation one? What are you talking about? Like what?
Like if you'd have a circle with, hold on, let me look at it, what I was doing. Like proving that circles are similar. You're given circle X with radius of R and all that.
Okay. Oh yeah, we didn't talk about concentric circles and congruent circles. So first of all, let's talk about what is a concentric circles. Concentric circles are circles that are within one another that share the same center. Okay. So this is an example of concentric circles. They have the same center, but different radii. Now, when it comes to circles, you need one thing to prove that circles are congruent. To show congruency of circles, the radius must be the same. So if you have two circles whose radii are the same, we can say that those circles are congruent. So if this was, say, 4, and this circle was also 4, we can say that these two are congruent circles. That means they're the same size. Now, in order for circles to be similar, the ratios of their radii must be the same. Okay, so what do I mean by that? Well, by its very nature, all circles are similar. Okay, all circles are similar to one another. Now, remember when we were talking about similar triangles? We had two triangles, and we said two triangles are similar if all the angles were the same, and all the sides had the same ratio. So, for example, if I had a triangle 3, 4, 5, and I had a triangle 6, 8, 10, then we can say that these two triangles are similar because they all have the same ratio. Okay, and remember what we call that ratio. We call that ratio a scale factor. And it was a hassle when we were proving triangles similar because not only did we have to show that all the sides have the same ratio, but we also had to show all the angles were the same. But with circles, it's a little bit easier because we don't have angles in circles. At least, yeah, to a certain extent, we do not have angles. So in order to show circles are similar, we just have to show what is the scale factor. And the scale factor is basically the ratio of the radii. Okay. Small to large or large to small. Okay. Now, let's say, for example, I have two circles and their ratio is the radii. Let's say the radii are 5 and 7. So one circle has a radius of 5, the other circle has a radius of 7. Now, the first circle has a circumference of, say, the first circle has a circumference of 10 pi. And the second circle has a circumference of 14 pi. How can we show that these two circles are similar? Okay. Well, if they both have, if the radii is 5 and 7, that means the scale factor is 5 to 7. Okay. So now we have to show that the circumference also have the same scale factor. So you put one circumference over the other and reduce. So the pi's cancel. And that's 10 over 14, which is 5 over 7. Okay. So if the circumference, the ratio of the circumference is the same as the ratio of the radius, then the circles are similar. Okay. Does that make sense, Dawson?
Yes, sir.
Okay, what else were they asking?
Like for that,
Yeah.
that was it basically.
Okay.
Pretty sure.
Okay. Any other questions? Okay, so
No.
okay, so remember tomorrow, by tomorrow you should have, and I think most of you already have this done. By tomorrow you should have the central angles done and the circumference and arc length. Many of you are just hammering it out at one shot, which I don't see that's not a bad idea. Okay. So it's up to you. I mean, if I was in your boat, I would just, suck it up and work really hard for 2 weeks and then get done with it and then never have to worry about geometry again.
So is there like any finals or anything?
We're still talking about it. Most
Still
likely
talking.
there will be, but for select students.
Gotcha.
Yeah. So. Okay, remember grades will be going in this afternoon or first thing tomorrow morning. So please have your assignments up to date by then. And yeah. Any questions? All right. So if there's no more questions, guys, have a great day.
All right, Mr. D.
Uh,
You, Mr. D.
All right, Mr. D.